Hello, everyone, and welcome to Virtual Planetarium Exploring Space, part of our MOS at Home programming. My name is Janine. My pronouns are she and her, and I'll be your moderator today. That means that I'll be reading some of your questions and responses, which you can submit below using the Q&A button at the bottom of your screen here in the Zoom meeting. If you'd like to see captions during today's program, you can click on the closed captions button at the bottom of your screen and select Show Subtitles. And if you're joining us on Facebook, we're so excited to have you here, but unfortunately, I'm unable to see your responses at this time. We're so delighted to have you all here today as our audience. Let's get started and meet our guides as we explore space.
Hi, everybody. My name is Katie. My pronouns are she and her, and today I'm going to be your guide as we explore space.
Hi, everybody. My name is Talia, and I'm going to be your pilot today, flying you along as Katie tells you some awesome things about our solar system.
Awesome. So Talia is going to be using a program called Worldwide Telescope, which is free and you can download it online. We'll have the link for you at the end of the show if you do want to check it out. So today we are going to be talking about Uranus, Neptune, and Pluto. Pluto is not a planet, but we'll talk about why, but I also didn't want to leave it out. But Uranus and Neptune are two planets that don't get talked about a whole lot. And part of the reason is because there's still a lot that astronomers don't know about those planets. Only one spacecraft has ever flown up close, and it was in the late 1980s. It was the Voyager 2 spacecraft. So really all that we know about these planets are from that spacecraft and then any types of observations that we can make either from the surface of the Earth or around the Earth. So there's still a lot to learn about these planets, but what we do already know is pretty awesome. So Talia, bring us into space, please.
Here we go.
All right, so we are looking at our solar system right now, and right at the crosshair is where the sun is, right in the center. And then from then out, we have Mercury, Venus, Earth, and Mars, which are all really close to the sun compared to those outer planets. Mars is that orange line there. And then if we keep going, we have Jupiter, Saturn, Uranus, and Neptune. And then that really kind of weird wonky orbit line is Pluto. So we'll talk about that and why we don't call it a planet and, you know, what happened to it and all that good stuff a little bit later. But our first stop is going to be to Uranus. So Uranus is nearly 2 billion miles away from the sun. So that spacecraft that I was telling you, Voyager 2, it was launched in 1977 and it flew by Uranus in 1986. So it took almost 10 years for it to actually get out here. And just for a reference, the Earth is about 93 million miles away from the sun. So we're talking about 2 billion miles. So we're very, very far away. And then, of course, we should probably talk about the name, right? Everybody loves the name, but it has kind of a cool story. So Uranus was the first planet that was actually discovered because out to Saturn, you can actually see all of those planets in the night sky with your naked eye. Uranus, you can't. It's not bright enough, so you need a telescope to see it. So it was the first planet that was officially discovered, and it was discovered back in the 1700s by someone named William Herschel. He was an astronomer. And originally, he wanted to name the planet George because he was from England and the reigning king at the time was King George III. But nobody let him do that. None of the astronomers in the International Astronomical Union or any type of, official astronomy panel wanted to let him do that because they wanted to keep all of the names from like Greek and Roman mythology. So all the names of the planets are the Roman versions of Greek deities usually. So Zeus is the Greek version of Jupiter. So Jupiter is the Roman version of the Greek god Zeus. And then Saturn is the Roman version of Kronos, which is Zeus's father. And then Uranus is the Roman version of the Greek god Oranos, who is the father of Saturn. So Uranus is actually Jupiter's grandpa, which is kind of a fun fact. Now, the reason that you'll hear a lot of astronomers and educators use the term Uranus, besides, or other than the other way of pronouncing it, which is totally okay and accurate as well, is because it sounds more like the original Oranos. It just kind of translates better, but either one is fine. So now that we're in orbit around Uranus, you've learned a little bit about the name. Let's make some observations about the planet itself. So if you have any observations, go ahead and put them in the chat.
Not seeing anybody yet, but I'm sure that they're thinking about what can they see with their eyes.
All
what
right.
do they notice? Ooh, my hero, age 11, says, it's so blue, and also wants to know why.
Yeah, that's a great question. So the gas planets, so Jupiter, Saturn, Uranus, and Neptune, the really large ones in the outer solar system, they're all made of gas. That's why we call them gas giants. But Uranus and Neptune are a little bit different in terms of their composition than Jupiter and Saturn. You can kind of put them together in pairs because they're more similar to each other than the two groups of planets are. So Uranus, a lot of what I'm going to say about Uranus is also true for Neptune as well. But these two planets are known as the ice giants a lot of the time, and that's not because they're made of ice necessarily, but there are ices in the atmosphere. So most of Uranus and Neptune is hydrogen and helium, at least in the main atmosphere part. And then once you get down deeper, astronomers actually think that there is like a water ammonia ocean really deep inside the planet, and then a rocky / icy core. And so there's lots of hydrogen and helium, but there's also a gas called methane, and methane is responsible for giving it that bluish color. Same thing for Neptune. And these planets have a pretty high percentage of methane, not as high as hydrogen or helium, but it does contribute quite a bit to the color. And this brings me to one of my favorite fun facts about Uranus and Neptune is that scientists think that it could be raining diamonds in the atmosphere of Uranus and Neptune. So methane is made up of carbon and hydrogen, but there's carbon in methane. And because it's a gas planet and it has lots and lots of layers of atmosphere, there's a lot of atmospheric pressure. So if you go far down enough, the pressure combined with the carbon creates diamonds. So we think that it might be raining diamonds. And if you go really far into the interior where the pressures are even greater, astronomers even think that there could be liquid diamond like oceans with diamond bergs floating on the liquid. And some of that is based off of experiments that they've done on Earth to try to simulate pressures like that. So it's not confirmed, but it's something really awesome to think about. They wouldn't be like beautiful cut diamonds like we have here on the Earth. And also raining diamonds does kind of sound a little bit scary since they are some of the hardest objects that we know about. But it's still pretty awesome to think there could be lots of diamonds inside of these planets. So I will pause there for a second and see if there are any questions so far.
We have some observations now, which is that there's a section of it that's not blue. Another person says, I see an orange spot. And then someone else asks what the dark spot is. So I'm not sure if that's all talking about that orangish, yellowish, greenish spot, but.
Yeah, so all of that has to do with the cloud layers of Uranus. So like we've said, it's made of gas, and Uranus spins as well. It takes about 17 hours to spin one time. And because it's made of gas, some parts of it are actually spinning a little bit faster than other parts of it. So areas around the equator are going to spin a little bit slower than areas near the poles. So that creates like different currents and bands in the atmosphere. It kind of separates out some of the different gases and things like that. So you might notice some differences in color because of this kind of stratification, like different gases in different parts, and just the fact that different parts are moving at different speeds. A lot of the like white streaks that you're seeing are clouds, methane clouds for the most part. And as for why the end of it is yellow, I actually don't know. My guess could be because there's a lot of ammonia in the atmosphere as well. So Saturn kind of has its yellowish color because of ammonia in its atmosphere. So it could be something similar to that, but I'm actually not entirely sure. Talia, do you have any insight into that?
It is all concentrated around the pole, as you can see. So what we're looking at here is one of the poles of Uranus. So it's very, I agree with you, it's probably ammonia gas, probably bound by jet streams around the pole, which is a phenomenon that we also see around Saturn and around Jupiter. Strong jet streams encircling the pole, probably leading to a buildup of ammonia gas in the upper layers.
Yeah, kind of keeping it all contained there. Definitely. So another interesting thing about Uranus that's kind of related to its rotation around the sun, so its revolution, is its tilt. So if you've ever seen a textbook image of Uranus, you'll notice a couple of things. So right now it's hard to spot, but Uranus does have a ring system. And so if you've seen a picture of it in a textbook, the ring system actually goes up and down. Instead of side to side like Saturn's rings. And that's because Uranus's tilt is extreme. Its tilt is 98 degrees. So for reference, Earth's tilted by about 23.5 degrees, and its tilt is why we have seasons. So when the Earth is tilted toward the sun, or the northern hemisphere is tilted toward the sun, that's when we have northern hemisphere summer. And when the northern hemisphere is tilted away from the sun, that's when we have northern hemisphere winter. So because Uranus is completely knocked over on its side, its tilt of 98 degrees causes really extreme seasons. So first of all, it takes Uranus 84 years to travel around the sun one time. 84 Earth years. So each season lasts 21 years. And because it's knocked over on its side during the northern hemisphere summer, that pole is directed pretty much right at the sun. So the entire northern hemisphere is in full sunlight for, basically the full 42 years, but pretty much just half of the year. And the other side is completely in darkness. So the kind of extreme seasons also causes some weird like atmospheric changes as well, because the heating of Uranus isn't very uniform across the whole planet. It's concentrated in different areas at different times. So let's talk more about the rings. So if you're wondering why Uranus is completely tilted, because the rings, they go vertically around the planet, and astronomers think that it's because 3 to 4 billion years ago, so in the early days of the solar system, at least 2 objects collided with Uranus, and they were probably Earth-sized, maybe even bigger than that. But they caused Uranus to completely fall over on its side. And so eventually, as the rings developed, which could have been from moons that got a little bit too close and got torn up around Uranus, but the rings ended up developing kind of along that equatorial region and going up and down rather than left and right or horizontal like Saturn's rings. So that's another cool thing. And that's what makes Uranus pretty unique, especially compared to Neptune, because they are such similar planets, but Neptune does not have the really extreme tilt. It also doesn't have as prominent rings as Uranus does. So I know you can't really see them super well right now, but that's mainly because they're made of mostly rock and dust, not super great at reflecting sunlight, but some of the outer regions of the rings are made of ice. So sometimes you can see pictures of the outer parts of Uranus's rings that actually look a little bit bluer and are slightly more reflective. All right, any questions about Uranus?
There was a question here that I liked that was the person was wondering, why do we say that Uranus is on its side and not that we're on its side? How do we decide what on its side means?
That is a very good question. And it's basically all arbitrary. We had to have, because there's no up or down or left or right in space, because, you know, it's just all around you. So we kind of had to decide, humans decided which way is up and which way is down. And so basically, anything that lines up with the like sun's northern pole, that's considered like the how would you explain it? Like the
I talk about like the plane
axis.
Right,
Yeah, the plane.
The equator of the sun being flat, the flat part.
Yes.
Yeah.
Yes, exactly. So basically, humans decided that this is how we were going to define these directions in space. And so it's all based off of how the sun is oriented, and then we just made it up from there. It also helps that a lot of the planets have minor tilts. So the one that's really, really different is going to be the one that, you know, is the anomaly rather than the more consistent tilts of the other planets. If that makes sense. Do we have any other Uranus questions before we move on?
One question of how big is Uranus?
Great question. I totally forgot to say that. So Uranus and Neptune are the smaller gas giants, but they are still pretty big. If you could open up Uranus like a cookie jar and try to fill it with Earths, you could fit over 60 Earths inside of Uranus. So it's pretty big. Jupiter, for reference, you could fit 1,300 Earths inside of it. So it is definitely a small gas giant. But Neptune is even a little bit smaller than Uranus. So we're going to head to Neptune. You could fit just over 50 Earths inside of Neptune. And Neptune is even farther. So Neptune is roughly almost 4 billion miles away from the sun. So I mentioned Uranus is about 2 billion miles. So we've basically doubled our distance. And Voyager, again, was the only spacecraft to have visited Neptune all the way out here, and it just did a flyby. And we see a lot of the same features on Neptune as we do on Uranus. It's blue, so it has lots of methane. It also has lots of ices in its atmosphere, and we think a water ammonia ocean as well, kind of deeper in the layers. We think that it could also be raining diamonds on Neptune. A lot of similar stuff, especially when it comes to composition. But one thing that is different about Neptune is that it has much more internal heat than Uranus does. And astronomers think that Uranus might have lost some of its heat because of the collisions that caused it to knock itself over, billions of years ago. And astronomers don't think that a collision of that size happened to Neptune, so it retained a lot of its internal heat from the early days of the solar system. And because of that, the atmosphere and the winds in the atmosphere are incredibly fast. Astronomers believe that that internal heating source is how Neptune's winds are the fastest winds in the entire solar system. They have been recorded to be 1,300 miles per hour in some places, which is faster than the speed of sound on Earth. And because of those really fast wind speeds, Neptune gets storms, similar to how Jupiter has a lot of storms on its surface, and it's got the Great Red Spot. Neptune also gets a lot of storms. And Voyager noticed when it was flying by, and Talia is getting us a nice close-up here, that it has a great dark spot. So it's just basically a huge cyclone on the surface, or in the upper atmosphere, like the surface layer of Neptune. Now, when Hubble took a picture of Neptune in the early 90s, that great dark spot was completely gone. So Neptune clearly kind of goes through these cycles of having lots of storms, and then they disappear, and then they reappear, and astronomers are still trying to figure out like exactly the mechanisms behind how these storms come and go. In 2016, so fairly recently, there was another picture taken of Neptune, and it discovered another great dark spot that had appeared in its northern hemisphere. And we don't know if it's still there because we haven't looked again. Access to the Hubble telescope and using it for, things like this is just not always possible. Astronomers are interested in a lot of what's going on in deeper space. So these outer two planets kind of get neglected a lot. So we don't know if it's still there, but it might still have a really massive storm. I forgot to mention the moons of Uranus and Neptune. So Uranus has 27 known moons and Neptune has 14 known moons, but this number could actually be a lot higher because, again, we've really only studied these planets from telescopes that are either on the surface of the Earth or in orbit around the Earth. So there could be a lot more out here. All right, and our last stop today is going to be Pluto. Everybody misses Pluto. We're going to, once again, nearly double our distance. Or not quite. We're going to go about another 1 billion miles out, though.
Merely another billion.
Yeah.
No big deal.
Not a big deal at all. Talia is very good at getting us through space very quickly, much faster than the speed of light. So before we start talking about why Pluto's not a planet anymore, I do want to briefly put in a little disclaimer here that what you're looking at is a rendition of Pluto before astronomers knew exactly what it looked like, because in 2015, the New Horizons spacecraft flew by Pluto for the very first time, the first time anything has ever gotten this close to Pluto, and it took pictures of its surface. So we actually have a much better idea of what Pluto looks like, and we can show you that in just a little bit. But I just wanted to let you guys know that what you're looking at right now is kind of an old, almost like an artist's rendition that's based off of some observation, but it's not completely accurate. So Pluto, it is not a gas giant. It's really tiny. It's made of mostly rock and ice. And if you were to compare it to the United States, it's only the size of about half of the United States. It could easily fit inside the moon. So it's very, very tiny. And if you remember initially when we were looking at the solar system, the orbit of Pluto is really weird. It doesn't quite line up with the other planets in the solar system. So it does have a lot of differences, but Pluto was discovered back in 1930 at a time where the only object past Neptune that astronomers discovered. So in our solar system. So it was the only thing out there, and it made sense to call it a planet at the time. But then we learned more about the solar system and had to change what we call it. So back before the discovery of Pluto, before even the discovery of Neptune, astronomers were looking out into space, and they discovered a whole bunch of objects that they were calling planets. And so at one point, our solar system actually had 16 planets in it. These objects were all discovered in between Mars and Jupiter. So over time, they started discovering more and more, and they were calling them planets, but then they realized that there were thousands of objects here in between Mars and Jupiter. So can anyone tell me what exists that we now know of that orbits in between Mars and Jupiter. And if you don't know, you can put a question mark in the chat.
I have somebody who's saying, I think what they're trying to say is Ceres. And also there's a question mark and then a whole bunch of question marks.
Yeah, so Ceres is one of these types of objects, but that's where the asteroid belt is. So there are millions of asteroids. They're very small, rocky objects in that region. Ceres was one of these objects that they found initially that they were calling a planet because Ceres happens to be the largest asteroid in the asteroid belt. So over time, they came up with this new classification for these objects because there were so many and they were all really similar in composition. And so those objects that they were calling planets, they stopped calling planets and turned them into asteroids. A very similar thing happened to Pluto. So like I said, it was the only thing past Neptune that astronomers knew about in 1930. And then in the late 1990s and early 2000s, they started figuring out that that is not true. So Talia, could we do like a view of our solar system and then we can show folks the asteroid belt and the other objects that are out with Pluto?
Get us recentered on the sun so that we can see it better.
Sounds good.
And let's look at some asteroids.
Yeah, so it wasn't until recently that these objects that are orbiting out with Pluto were discovered. There are tens of thousands of objects that astronomers have found, and they presume that there are hundreds of thousands of objects all the way out there. So Talia just put up the asteroid belt for us. So that's between Mars and Jupiter. And then all the way out here, we can see objects in what's called the Kuiper Belt. Very similar to the asteroid belt, just farther away, a bit icier. And so when we compare these objects to Pluto, we see that they're made up of a lot of similar they're just of stuff, of material. They have a lot of ice and rock and this like ionized surface material that ends up kind of looking reddish over time. And so it actually started to make a lot more sense to start calling Pluto a Kuiper Belt object rather than a planet. You might have also heard the term dwarf planet. A dwarf planet is any object that is massive enough to be round for gravity to pull it into a round shape, but it doesn't fit the other criteria to be planets. So we've got Pluto as a dwarf planet. There's a few others in the Kuiper Belt, and then Ceres, the one that was mentioned already, that's in the asteroid belt, is also considered a dwarf planet. So there are 5 officially right now, but that number will probably go up as we learn more about the Kuiper Belt. But let's go ahead and zoom back into Pluto so we can show everyone the true Pluto before we end the show today. So New Horizons was launched back in 2006, and pretty much right after it was launched was when astronomers decided to stop calling Pluto a planet, which is just kind of funny. But New Horizons was the first mission to Pluto, and it gave us this beautiful up-close look at its surface. So this now is real data based off of real images and surface textures and things like that. And now astronomers know so much more about Pluto. They kind of assumed that it would be like this very cold, barren place, kind of like the moon. No offense to our moon, but just not a whole lot going on because it's so far away and it's very small. But it turns out that there's actually geologic activity believed to be happening in Pluto. So there's some kind of internal heating source that is driving these processes, and because there are mountains on the surface of Pluto, there are volcanoes that shoot out ice instead of lava. They're called cryovolcanoes. And there are canyons and there's glaciers of nitrogen ice on the surface. So there's just like a whole lot going on Pluto that's really awesome. And we're still learning a lot more about it as, astronomers continue to analyze the data from this really awesome spacecraft called New Horizons. New Horizons is now far beyond Pluto. It's exploring the Kuiper Belt, some of those outer icy bodies, and will eventually just continue to float out into space. All right, so I don't know, do we have time for maybe one question, Janine, if any have come in so far? I talked quite a bit.
Let's go with, why do planets have moons?
Why do planets have moons? Great question. So planets form from lots of material around stars that clumps together, and moons form in a similar way. It's just material that didn't go into making the planet, that was orbiting kind of around and clumped together to form moons. There's another way, though. Moons can also be captured. So if an asteroid is floating by, it gets too close to a planet, the planet's gravity can actually capture it. And so we call those captured moons. So they can form in pretty much either of those two ways, or they can become moons in either of those two ways.
And I'd point out that not every planet has a moon. These two, Mercury and Venus, have 0.
That's a good point.
Alrighty, I think that's all we have time for today. Thank you guys so much for taking us on this journey through space and showing us all these cool things and learning about all of these ice giants and friends out past Jupiter and Saturn. I'll let you guys say goodbye and all that good stuff. Thank you all for joining us today. We hope you had fun and learned something. I'm sorry that we couldn't get to all of your questions. There were lots and lots of good ones. But unfortunately, we only had time for a few, but hopefully you enjoyed the time anyway. If you did enjoy this program and you want to see more programs like this, you can keep an eye out on our social media channels or check out mos.org/MOS at home to see what else is upcoming. And if you enjoyed today's presentation and would like to support more programming like this, you can visit engage.mos.org/welcome to support MOS at home. And as we mentioned earlier, as Katie mentioned earlier, this program today was produced using Worldwide Telescope, which you can find at www.worldwidetelescope.org, just as it is written on the screen there. Thank you all for joining us and hope you have a wonderful rest of your day.